If you followed along in our last two videos, you saw how numbers are built using prime cards and how they reveal fascinating patterns. But the journey doesn't stop there. Ready to uncover more number patterns? Let's jump right in. Imagine we are building the number 30. We attach a card of 2, a card of a 3, and a card of 5. That's how 30 is built. Remember, attaching prime cards means they are multiplied. But what if we start detaching cards instead of attaching them? Let's try it. First, if we detach the card of 2, what do you think we get? Correct! We get the factor pair 2 and 15. Now, instead of detaching the card of 2, let's detach the card of 3. Can you guess the factor pair? Exactly, we get 3 and 10. And if we detach the card of 5, what factor pair do we get? Perfect! We get 5 and 6. Well done! What happens if we detach a card of 2 and 5s together? You got it! We get the factor pair 10 and 3. This was already created above when we detached the card of 3. Notice how the factor pairs are repeating. And if we detach the cards 3 and 5s together? That's right. We get the factor pair 15 and 2, just as we did when we detached the card of 2. Again, we see the repetition of factor pairs. And if we don't detach anything? We get the factor pair 1 and 30. Detaching nothing means the number is divided by 1. Do you notice something? Pause and think about it for a moment. Great observation! Every time we detach one or more cards, we create a factor pair. The cards we detached is one factor. The remaining product is the other factor. Pretty cool, right? Now that you have built the factors of 30, let's try to build factors of 8 using the same method. Take a moment to find all its factor pairs. Let's explore another interesting pattern. Take a step back and look at their factors again. 8 is built using 3 cards of 2 and has 4 factors, 1, 2, 4, and 8. 30 also has 3 prime cards, cards of 2, 3, and 5, but it has 8 factors, 1, 2, 3, 5, 6, 10, 15, and 30. Why does 30 have more factors than 8, even though both are made from 3 prime cards? Yes! It's because the more different prime cards a number has, the more ways it can be detached into factors. Numbers like 30 or 42, built from many different prime cards, have lots of factors. But numbers like 8 or 16, built with identical cards, have fewer factors. Here's a fun task for you. Try finding the factors of 12 and then compare the number of factors with 8 and 30. You will be surprised by the pattern. Share your findings in the comment box below. Did you like this video so far? Why not share it with a friend, classmate, or even your maths teacher? They will enjoy exploring these patterns too. Now, let's take a closer look at another example, the number building of 24 and 54. Can you write down the factors of 24 and 54? You got it! The factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. And the factors of 54 are 1, 2, 3, 6, 9, 18, 27, 54. Now, which of these factors are common between 24 and 54? That's right. The common factors are 1, 2, 3, and 6. Do you see all these common factors in the number building of both 24 and 54? Excellent! Now let's explore a bit deeper. What is the largest group of prime cards that both buildings have in common? Think about it for a moment. Fantastic! The largest group of prime cards common to both buildings is 6. If we add any extra prime card to 6, the new number will no longer appear in both number buildings. For example, if we attach a card of 2 to 6, the new number can be seen in the number building of 24, but not in 54. If we attach a card of 3 and instead of 2, then the new number can be seen in the number building of 54, but not in 24. Let's think of it another way. What is the biggest number we can detach from both the 24 and 54 number buildings? Correct! The biggest number we can detach from both buildings is 6. It's the largest number of prime cards they have in common. In other words, 6 is the biggest number that divides both 24 and 54 perfectly. That's why it is the highest common factor, HCF, of 24 and 54. Let's see what happens when we compare the number buildings of three numbers, 30, 42, and 105. 30 is built with the cards of 2, 3, and 5. 42 is built with the cards of 2, 3, and 7. 105 is built with the cards of 3, 5, and 7. Notice how each of these numbers is built from a combination of prime cards. Can you spot any common prime cards among these three buildings? Let's check for the common prime cards. For 30 and 42, they have the common primes 2 and 3. When we look at 30 and 105, the common primes are 3 and 5. For 42 and 105, the common primes are 3 and 7. But what is the largest group of prime cards common among all three buildings? That's right. It's 3. So, the highest common factor, HCF, of 30, 42, and 105 is 3. This is the biggest number that divides all three numbers perfectly. Here is a challenge for you. Can you find the HCF of 18, 27, and 45? Look carefully at their number buildings and identify the largest group of prime cards common among all three buildings. Congratulations! You've understood the concept of factors and HCF. Keep up the great work! But wait, there's more patterns waiting to be discovered. What if one number is already a factor of another? For example, let's take 6 and 12. Since 6 is already part of 12's number building, the HCF is simply 6, the smallest of the two numbers. This happens every time one number is a factor of another. Can you tell me why? Drop your answer in the comment box. Now, here is another mind-blowing pattern. Why is the HCF of two consecutive numbers always 1? Let's take 8 and 9, or 14 and 15. Do they have any common prime cards? Exactly. Since consecutive numbers never have a common prime card, their only common factor is 1. This means their HCF is always 1, making any two consecutive numbers co-prime. Want to test this out? Pick any two consecutive numbers and check for yourself. Do they ever have a common prime card? Before we wrap up, here is a challenge for you. Can you find two numbers that have a HCF of 1, but are not consecutive? Look carefully, there are plenty of examples. By now, you have seen how number buildings and prime cards help us understand factors, common factors, and the HCF in a simple, visual way. But this is just the beginning. In the next video, we will uncover even more patterns hiding inside numbers. We will dive into multiples, LCM, and uncover how factors and multiples are connected.